Okay, so welcome back, and this is probably going to be the last question we do for today. And since my neck pain is kind of killing me, and we're still on exam one from 2015 fall semester, and we're on question number 15. Consider the following successive ionization energies. Which element would most likely show its trend in ionization energies? So if you remember from your class, well, I guess I probably should stop saying it. It sounds kind of offensive a little bit. So, well, electrons are kind of like people that I don't know. Some people just get abused in the society in order for for the others to be happy, I suppose. So it's kind of like the valence electrons, like the core electrons are the non-valence one. The core electrons are kind of like the ones in the castle. So it's a castle over here, and all the non-valence electrons stays inside the castle, and the valence ones are on the outside of the castle. They're like the slaves of the medieval times, or I don't know. They don't really have friends, I guess, I suppose, and so they get out to fight whatever to do the chemical reactions and all the other stuff, and the non-valence ones gets to stay inside and have like I don't know, have a drink or stuff, a drink maybe, and with their friends, since they probably have friends. Yeah, and there's also the core of the electrons. They're like the king and the nobles. They stays exactly in the middle, and they attracts everything to them. Like every electrons is probably for the purpose of serving them. And there's the castle, and if you just like if there's a monster coming and take out like a monster, it doesn't look like a monster. Never mind. I probably don't have any artistic skills. Like a monster, a giant octopus, squid, whatever, with one eye only. It will come in and take out. It's not pretty. Well, I guess it doesn't. Ah, Lord, it's killing my octopus, whatever. The giant octopus with like antennas on the top, maybe, and has a one eye only. It can probably just drag out and eat one valence electron very easily, and he can does it for the second one, which will probably take out more energy, but it can still be doable, and he can also take out the third one and the fourth one until it takes out all the, well, in this case there's 6 of them, so I'll draw 6 little fighting slave over here, so they will all be swallowed. And although it takes more and more energy to swallow each one of them, since I guess they're kind of fighting they probably have some swords or so. Oh, the purple is the monster color. They probably have some kind of like a sword or dagger or whatever, a shield maybe, like a circle or whatever. They probably have a small dagger or stuff like that. They fight the monster, so it takes more energy. It takes more, as you can see over here, it takes more energy to swallow each of the fighting slaves outside the castle. But however, when all the people over here has been eaten or I don't know, just dragged away, it took slightly much more energy to drag a people from the inside wall. Circling. Since it has the castle to protect them, and it has a longer reach to the core electron, so as you can see there's quite a jump over here, a jump. This is serious stuff, so I used the serious color. I used my serious color to do it. So this is the jump. And the jump actually shows that the monster just getting to the jump actually just shows the monster that actually gets into the castle and dragged one of the non-valence friends outside. And so I guess it kind of gives you the idea about, like, for this particular whatever this molecule, whatever this atom is, it has 6 valence electron, and for the seventh one we drag, it's in the castle, so it's a non-valence. This one is actually a core electron. This one is a core electron, and these are all valence electrons over here, and this is the core electron. So let's take a look at the periodic table and find out which one of these has exactly 6 valence electrons, which according to my memory it should be sulfur over here. It's 2s2 2p4, so it has exactly, so it's the core with 2 electrons on the second level, the core with 2 electrons on the second level, and 6 on the third level. So it should be sulfur. It's 2s2 2p4, and I believe D is the correct answer. Let's end up over here. Well, it's a kind of fun story that, but the fun part is actually while these vulnerable, poor fighters on the outside is actually the determinant of the atom, at least the chemical property of the atom, the determinant of the chemical property of this particular atom. So I guess the word is kind of fair, that since you're the one really fights, you're the one really fights the monster, you're the one that really matters. But well, I guess the society doesn't works like that all the time, but well, hopefully a fair society does work like this. Anyway, well, I'll probably end up today over here, and let's see if we can do more tomorrow.